Okay, let's do some of these problems. So on this combined gas law, turn to where it says homework and we're starting the problems. I don't know what all you finished, so I'm just going to pick some and then we'll have time to work with partner and then we'll be around to help you out. So I'll start with number 1. Maybe you have that completed, maybe not. So number 1, this last part of the notes talked about collecting a gas over water. So that's what this problem is. It says some hydrogen gas is collected over water. So you were to, listen, to write this equation, collecting gas over water, P pressure of the atmosphere equals the pressure of the gas that was collected over water plus the pressure of the water, because water vapor is going to be mixed into that gas because it's over water. Okay, so it says the levels of water inside and outside of the gas collection are the same. That means that it equals the pressure of the atmosphere. The partial pressure of the hydrogen gas is 742.5 torrs. So that's for this gas that was collected over water. This part in the equation right there.
P-goo?
It says gas. What is the barometric pressure at the time the gas is collected? So that is the pressure of the atmosphere. So that's your unknown. So I'll just put an X there. So we're trying to find the atmospheric pressure. Okay, now we need to find the pressure of the water. In order to do that, we need to know the temperature and look at the table before. So the temperature is 20 degrees Celsius. And find 20 degrees Celsius on this table. It is right here.
17.5.
Yep, that's millimeters of mercury, but that's the same thing as torrs because it'll be the same like number. So we're going to use 17.5 torrs for the pressure of the water. So how do you find X? You just add those two up. So 742.5 plus 17.5. 759, whoops, and that is a 1. So we got 760, right? So that's how you use that equation.
That's what I thought it was.
Gas. Okay, moving on. Let's go. Shh, guys, quiet. Number 3, a sample of gas at 47 degrees Celsius. So when you see Celsius, you know that it's temperature. So right away, just put T and put what it is. So as you're reading it, I would write down your knowns, and that helps you figure out what equation to use. And then 1.03 atmosphere. So what variable is that? Atmosphere is a unit for pressure. We'll get it. And it occupies a volume of 2.2 liters. What volume? So they're asking for a new volume. So that must be volume 2. So this must be volume 1, pressure 1, temperature 1. Would this gas occupy at 107 degrees Celsius? So that must be temperature 2. What should we add to Celsius to get it to Kelvin? 273. That's on your note card if you don't remember or need to figure it out. And at that degree, the pressure is 0.789. So that is pressure 2, 0.789 atmospheres. Okay, so we have P, T, and V. What variable always goes on the bottom? T. So that's how you set it up. So you put P and V on top. One side is 1, the other side is 2. Doesn't matter which side you make 1 or 2. Okay, what variable are we solving for? V2. Very good. So how do we get V2 by itself? We need to get T2.
T and P.
Yeah. Both sides by T2?
No, just the top. And then P goes to the bottom.
Yeah. So cross multiply, T2 comes over here. And then P2 on the bottom. That's what Owen said. That crosses it out over there. Okay, so what is T2? 107 plus 273. What do you got? Yeah. Yep. And then P1 is 1.03. Oh, just so you know, I got 380 right here when I added 273 to it.
Wait,
Sorry.
but that's T1. T1 on the bottom.
Oh, I'm sorry. I meant I got
That's T2.
308. Just kidding. I got 380 right here when I add 273 to it. Sorry. And then V1 right here. What's V1? 2.2. Do you got that? And then on the bottom is P2. 0.789. And T1, 47 plus 273. 320? 320. So 320 right there. Now we can solve and we can find volume number
V2.
2.
Oh my god.
Is everything okay? Okay, put parentheses if you're going to do the whole thing at once. What do you get? 3.41. What is the unit? Volume 1 was liters, so volume 2 is liters. Yep. No one disagreed, so.
I don't know.
Yeah, I'm gonna come down in the morning next week sometime.
Okay.
No, I got it. I just.
Okay, let's flip the page. I'm just going to try to find the different questions for each equation so you have an example. Okay.
Guys, if working on your own, just work quietly.
Yes, please. So these questions, they tell you what law to use. So Boyle's law, Charles' law, but you should be able to figure out on your own. But okay, let's do a Boyle's law here. So number 1, yeah, if you want to work ahead, just quietly do so. But stay quiet so we can hear. A gas has a volume of 300 milliliters at millimeters of mercury. What is that unit for pressure? Because pressure is torrs, atmospheres, millimeters of mercury, kPAs. What will its volume be? So it's asking for the final volume. So V2 is our question mark. If the pressure changed to 500 millimeters of mercury. So the pressure is now 500 millimeters of mercury. So we have P and V. T is the only variable that goes on the bottom. So what do we do with P and V? We just multiply them because only T goes on the bottom. So it's Boyle's law, right? There's no T, so nothing goes on the bottom. That was my point. So we are solving for V2. V2 is our question mark. So how do we get P2 on the other side?
Yeah, so from the bottom, it'd be P1 or V1 over P2.
Or you can say like cross multiply and it goes on the bottom. So that is our equation that we're going to plug our numbers in. P1 is 300. V1 is also 300. And P2 is 500. So 90,000 divided by 500. What'd you get? 180? What's the unit for that?
Millimeters.
Yep, very good.